Okay, thank you so much for having me. Now I'm going to talk about a project that we started with Holger Essler. He's from University of Würzburg, and I'm a physicist from Jagiellonian University in Krakow. The aim that Holger set in front of me was basically what can we do, or can we improve any metadata of the papyri databases with our stylometric methods. So you've got a couple of different metadata that exist there in their databases, which are, for example, the authorship, but also the genre or the type of the documents or the other papyri, the place where they were composed or found, or their date of being composed, and so on. So the basic question is, can we have any information about all these metadata from the texts themselves? Particularly what I deal with is authorship attribution. So that's going to be the narrowed down presentation to that particular thing. So can we actually find out who the authors of these texts are? Now, the data that we use is from two databases. One is the papyri info. This is the database of documents, which I'm not going to talk about today. The other one is the database of literary papyri, and that's the main focus today. They are actually connected in a way. So you can actually go just to their GitHub page, and you have access to all the data they have outright. So it's totally free to do that. Next, this database is connected to another database, actually a couple of them, but one that we use for getting the metadata is the Leuven database. So as you can see, there are several, more than 10,000 papyri described in the database. But the problem is that if I want to work on the texts, there are very few of them. Then even more so, you still can have a little bit more text that come from the papyri document database, but these are not really literary ones. So since we know that genre or document type is kind of meddling with authorship attribution, for now we get rid of it. So we're left with those, but then of course there's even more the kind of selection. We want to just have one language, want to know the authors to do the training or any type of machine learning algorithms here. And you want something that is long enough to actually be attributed. And that's a problem. So there are basically 300, at least when I worked on that. So people transcribe those texts, every now and then. So probably there's more now, but it's still a very small data set. So it's I don't think it's feasible for like neural networks, which really need quite a lot of data. That's basically what the metadata would look like. So you'll see, for example, the place of where something was found or written, and you also have those links to Trismegistus database, which tells you also something about that place, where it is located, if we know that, or where and when it was mentioned in some documents, and so on. And the same for the authors. So there's much more that we can, much more information that we can actually link to do some more work. Now, we still want to get familiar with the data. So some problems in machine learning just come from the fact how the data is structured, in the sense that here you can see that there's like just one author that wrote 70 texts from that from our collection, and there are 40 authors that just wrote one text. So that's very uneven distribution, and it is a problem for machine learning and for evaluation of machine learning methods. Usually. Also, the length of the text is very varied, from several thousands to just a couple of hundred words. So in stylometry, you would normally try to attribute authorship to something that's in this range, so several thousand of words long. So really, we expect to have problems. So we know the region, which is also usually localized in just a couple of places that we've found most of the papyri. And the last thing is just the dates. So there, the dating can be as broad as a couple hundred years. So we would like to narrow that down at some point. And the next thing is, we don't work with just pure text. It's annotated text, so manually annotated by the editors. So there's a lot of information here that tells you that, okay, that some letters were unclear and we are not really sure of those, or there are some other choices that that the editors have made. So there are some information that basically we don't have to worry about, like line breaks and paragraphs and so on. There are some that we are going to use, which are correction of the spelling and so on. And there are some things that will affect our prediction. So you can see that, well, you could expect that some texts will be different because there were some different conventions in different times. I mean, a couple of hundred years apart can be really different conventions of writing or of orthography and so on. So we're going to try just two ways of processing the data. So we either try to regularize, standardize all the text, or we want to diversify them. Now, as to the methods that we try here, I just stick to whatever we already had at hand. So in Stylometry, we usually use quite successfully methods based on text similarity, based on word frequencies or n-gram frequencies or post-tag frequencies, whatever you have. And of course, there are many of those text similarities that are known. Any smart person will try to tweak the distances for their favor. And then, again, we use very classical hierarchical clustering algorithms, which is, we use them because we've tested them on many modern novels, so we know how they behave on the type of linguistic data that we deal with, and so we can just exclude some of the methods that we're quite sure are not going to perform well. Another thing is, that's also a way of clustering data in an unsupervised way. So you can think of those nodes here as texts, and the links between them, the strength of the links represents the similarity of those texts. So then we can group those texts together in, and then we can interpret that, maybe those are actually authorial groups or genre groups or something else. So that's another method that we want to try. And for, I guess, 15 years now, there have been developed very good methods to do that for any graphs. The problem is they usually do not work for text similarity graphs because they have very kind of flat structure. Everything is connected to everything. So we need to do some filtering before that. So we just take from each text, just a couple of strongest links. So then there are less links left in the graph. And then how we measure the quality of our results is actually very non-trivial as well, because of the diversity of the data. So there are a couple of indices that wouldn't really be very informative. Even something that's used most commonly, like RAND index, is not a very good index for measuring quality of the clustering. You have to adjust it, and then it's still not very good. So what we go for is the adjusted mutual information. There's still a better way, but it's hard to implement it. So we still are not there to get the best one. And there's still some selection bias in how this scoring will work. So just going to the results, yes, it's hard, okay? So don't expect too much. So what you get, so there's this adjusted mutual information. What you would get from random clustering is 0. What you get from perfect clustering is 1. This is a very low score for network clustering. And we expected it to be kind of low, but it's kind of bad. The thing is that something that was kind of successful, I mean, for years and years in Stylometry, is really performing terribly for those short texts. I mean, the Barrows delta. The cosine distance delta, it's working still the best out of all the methods that we've tested. And as you can see, I mean, for the novels in I know, like in English language or German or French, this would go up to 0.6. But just keep in mind that it's not supervised, it's unsupervised. We have no idea what's in the data. We just want to see if there's any structure in the data that we can use later on. Just to show it graphically to you, these are those maximal best clustering for this given method. The funny thing is, it depends on the way that you standardize your text. So actually, these red lines, so these are the best results, which are for normalized text. If I want to keep all the diacritical marks, I want to keep all the diversity of orthographical notations, I actually get lower results. So that's something that will be important, I think, in later studies. And that's something that I'll just go back to in conclusions. So you can see that actually the problem also is just the size of the text. If the texts are large, they're just clustered together for some reason. So just summing up. There's some interesting information in the way that we standardize the text. And that's some trade-off, I believe, between how sparse the feature vectors are and how many different diverse individual features we have. So there are quite a lot of problems with just what data we get, and we can't make it really much better. Maybe we can make it better with, for example, texts that we can augment from, not from papyri, but from medieval transmissions in some codices. And we have some other methods still to try out. So this is Holger, that's the main contributor, who's a papyrologist, and the other guys are just, well, they give me the environment to work on those kind of topics. So on our webpage, I will soon give the code in R how to, you can access the data and how I work with it. So thank you, and if there's still time for questions.
Are there any questions? Getting near the end of the conference, questions are diminishing. I don't know much about Stylometry, so I So,
No worries.
thank you, speaker, again.
Yeah, thank you.